Class, good day and welcome to another episode of our topic in physical science, properties of molecule based on its polarity. By the way, my name is Christian Amorque Rizala, your teacher in physical science. Narinig nyo na ba ang kantang Tubig at Langis? Nasubukan mo na din bang maghugas ng pinggan na sobrang napakasek? Kung lalagyan mo ng mantika ang tubig, anong mangyayari? Ito ba'y humahalo sa isa't isa o hindi? Kahit pa ito'y lagyan natin ng init. Lahat yan ay pag-uusapan natin ngayong araw, kaya dapat tapusin ang ating online class para mas maintindihan natin yan. And before I forget, bago ko makalimutan, don't forget to put your attendance dyan sa comment box. Dapat meron kayo dyan name and section and say present. Alright? Para makita ko kung nag-attendance kayo. But make sure to watch the entire video from start to finish kasi lahat doon magre-rely sa assessment and performance tasks. Before we begin our discussion, I would like to ask some favor to all of you there. Sana class, while discussing, you have your pen and paper ready to take down notes sa mga di-discuss natin. Kasi some of the discussion natin dito ay napaka-importante para masagutan nyo yung assessment at saka mga performance tasks. I hope na you have your pen and paper ready to take down notes. Okay? Let's talk about solubility. Ano ba ang solubility? Let's define the solubility. Is defined as the solid ability of a solid substance to be dissolved in a given amount of solvent in a given temperature. Unang example natin dyan, yung asukal at tubig. So, if I have to put water sa isang container, no? Let's say, ito nga, naglagay ako ng tubig sa tasa and then I put sugar on it. What will you notice doon sa kanyang mixture? So, hahaluin natin siya. Diba? Nakita nyo naman kanina yung asukal nasa ilalim. No? And then, once you stir using spoon, eto, check natin kung ano mangyayari sa asukal. Na-dissolve siya. So, na-dissolve yung asukal. So, meaning, ito yung tinatawag nating solubility. Diba? Solubility meaning is defined as the ability of a solid substance to be dissolved in a given amount of solvent in a given temperature. Ito kasing tubig natin, ang tawag natin dyan ay solvent. No? Huwag nating kalilimutan na ang water ay solvent. No? Nilagay natin si asukal and then si solvent in a form of water. No? Di naman siya ganun kalamigan. No? Lukewarm, medyo yan. Madidissolve yung ating sugar. So, that's what we call solubility. Next is what we call the miscibility. Miscibility is the ability of the two liquids to combine or mix in all proportion, creating a homogeneous mixture. When you say two liquids, no, dalawang klase ng liquid ang paghahaluin natin, no, equal size. One good example, yung tinatawag nating solvent nga, no, yung tubig and milk, yung gatas at yung tubig, paghahaluin natin siya. So I have here an example of miscibility, no? Yung tinatawag nating two liquids to combine in all proportion, creating a homogeneous mixture. So yung sinabi ko nga example is the milk and the water. So, I have here an example nga, milk and a vinegar. So, naglagay ako ng two example regarding with miscibility. So, the first one is the milk. So, I'm going to pour the milk sa water and then I have to stir it. Haluin natin siya using the spoon ng kutsara. So, as you can notice, no? Yung milk na nilagay natin sa tubig, naghalo sila in all proportion. So, hindi mo na ma-distinguish dyan kung saan ang tubig at kung saan ang gatas. Kasi nga, yung dalawang liquid na hinalo natin nag-form sila sa isang liquid. Yung next example naman natin yung vinegar. So I have here a water and a vinegar. So binuhos natin yung vinegar sa tubig, and we have to stir it using the spoon, just like the procedure what we have did dun sa milk. As you can see, hindi mo rin ma-distinguish ngayon dyan kung alin dyan ang gatas at saka, vinegar and the water, kasi nag-combine nga sila ng mixture para sa isang liquid nga. So, ganyan yung tinatawag nating miscibility. So, pag pinaghalo natin ang dalawang liquid at naghalo sila, no, automatically that's what you call miscibility. So, marami pa tayong example ng mga miscibility natin eh. Mga orange juice, ilalagay sa tubig, no? Coffee, what else? Marami yan, no? So, yung mga powdered drinks natin, so pwede yan. So, that's what you call miscibility. Let's move on to immiscibility. No? Kung yung kanina, miscibility, the next is immiscibility. Yung parang reverse niya. So, it means that not forming a homogeneous mixture when added together. So, pag yung dalawang liquid, hindi daw siya nag-form ng homogeneous mixture. No? Hindi siya nahahalo. So, one good example of the immiscibility, yung water and oil. Pag pinagsama natin yung water and oil, kaya nga yung kantang sinasabi ko na tubig at langis, no? Kapag pinag-aralan natin mismo yung lyrics niya, parang ganito yun, no? So, parang tubig at langis. So, okay. So, let's have an example of the water and oil. Right? In water and oil, no? So, meron tayong glass dito, and then I have to put water on it. So, lagyan natin siya ng tubig. And then after pouring water sa glass, isunod naman natin si oil. Actually, you can use cooking oil dito. Kahit na anong oil pwede mong gamitin. So, habang inilalagay natin si oil sa tubig, pansinin ninyo kung ano yung nagiging position ng dalawang liquid. Huh? So, continuously pouring the oil sa water, makikita natin na nagkakaroon sila ng tinatawag na spacing. Si water nasa ilalim at si oil laging nasa taas siya. Kasi nga, si water ay mas dense kaysa kay oil, kaya si oil palaging it will stay on top pag pinaghalo natin yung dalawang liquid na yan. Kaya dito pumapasok yung tinatawag nating ruling na likes dissolve likes. Kung sino lang ang mga magkakatulad, sila lang yung nagmi-mix. At kung hindi sila magkatulad, hindi sila nagmi-mix. Katulad na lang nung tubig at langis. Hindi mo to pwede kasing paghaluin. Likes dissolve likes. Bakit kaya? Kasi yung tinatawag nating polar and non-polar substance. Kasi nga, si langis, no? Si langis ay isang non-polar substance. At si tubig ay isang polar substance. Kaya hindi mo pwedeng paghaluin ang polar at saka non-polar. One good example of polar substances ay tubig, no? Yung solvent. Tubig, vinegar, mga food coloring. Ito yung mga few examples of polar substances. While the non-polar substances naman, no, yan yung ginawa natin kanina na pinaghalo natin, yung oil, langis, isa siyang non-polar substance. At meron naman tayong butter, no? Butter, yung dairy cream. O kaya gasolina. Kapag itong mga to, hinalo natin sila sa polar, hindi sila pwedeng maghalo kasi nga likes dissolve likes. Magkaiba kasi yung kanilang chemical properties para maghalo. Dapat kasi parehas. Kaya napapansin niyo pag pinaghalo silang isa at si tubig, palagi silang magkahiwalay at nagkakaroon sila ng mga layer. Alright. Paano nga ba malaman kung polar and non-polar? How to know? With our previous topic, dun sa naunang video na ginawa natin, di ba meron tayong pinag-usapan na tinatawag nating electronegativity. Ibig sabihin, by means of electronegativity, malalaman natin kung ang isang substance or isang element ay non-polar or polar. Dito sa chart natin, kung maalala ninyo before, the type of bond, we can distinguish whether it is ionic, polar covalent, or non-polar covalent. Doon sa electronegativity difference natin, which we refer to the periodic table kasi meron naman yun doon nakalagay sa periodic table. So doon tayo magre-refer. So gagawin lang natin, di ba? Pag kinag-combine yung dalawang klase ng element, kapag lumabas yung electronegativity difference nila, 1.7, 0.5, 1.6, 0.4. So dyan natin malalaman yung tinatawag nating polar ba siya o non-polar, or pwede rin sabing ionic. So dito tayo lagi mag-refer sa electronegativity. Intermolecular forces, or we call it as IMFA, are the forces of attraction or repulsion which act between neighboring particles, such as the atoms, molecule, or ions. So there are several types of IMFA, and below are they arranged from the strongest to weakest. So we have the dipole or ion dipole, we have the hydrogen bonding, dipole-dipole, dipole-induced dipole, and the London forces of attraction. Uni-negative chloride ions na merong polar molecule na water. So kapag ang sodium chloride naman ay dinisolve natin sa water, nagdi-disassociate sila into respective ions, and the positively charged sodium ions are attracted by the negative charge of the water molecule. Kasi dyan sa loob ng tubig natin, meron tayo mga positive negatives na charges. So wherein yung mga sodium, yung sodium natin, since positive siya, ma-attract ngayon siya sa negative water, which is the H2O, negative. While the chlorine naman, ma-attract naman siya sa mga positive H2O, since si chlorine kasi ay negative. So, yun ang mangyayari niya, no? So didikit lahat ng mga negative, mga positive kay chlorine kasi sabi nga nila, positive charges attract with negative and negative attract with positive. Hydrogen bonding is primarily electrostatic force of attraction between a hydrogen atom, which is covalently bound to a more electronegative atom or group, and another atom, electronegative atom, bearing a lone pair of electrons, the hydrogen bond acceptor. What are hydrogen bonds? These are an attractive force called hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bond because it takes less energy to break these types of bond. However, a large number of bonds going to one can exert a strong force. Hydrogen bonds are the result of unequal charge distribution on a molecule. These molecules are said to be polar, tulad ng tubig yan. Kung titingnan natin ang molecule ng tubig, yung mga atoms share electrons with two different hydrogen atom. So in total, this molecule has 10 protons and 8 from oxygen and 1 from the hydrogen atom. Kaya naging 10 siya. Kasi nag-shared nga yung dalawa, yung 8. So the oxygen atom are shared 2 between the oxygen atom and hydrogen atom, 2. And the other 6 non-shared electron from the oxygen atom. So this water molecule is electrically neutral. Neutral siya, wala siyang charge. But it has a partial positive side and partial negative. So meron siyang negative and positive yung side niya. Kaya the electron are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that N a slightly negative charge. So the hydrogen atom N of the molecule will have a slightly positive charge, laging konting positive charge, At saka yung end naman, na-attach doon sa positive end ng one molecule ng tubig. At yung negative naman, ay adjacent sa water molecule. So kung ang tubig ay in a liquid form, there are few hydrogen bonds in solid form. So many hydrogen bonds when water is steamed from the gas bond because the water molecule are too far apart from any bonds. So the hydrogen bond only form between hydrogen atoms that are covalently bonded. So kung oxygen, nitrogen, and fluorine atom, hydrogen bond are also important in the structure proteins. So ang nucleic acid, which we will cover in the later topic natin. And we know that water molecules are polar. Alam naman natin na ang tubig ay palaging polar yan, no? In fact, many lipids or fats and oil are not polar. Tulad ng mga taba, langis, oil, yan ay mga non-polar, no? Kasi hindi naman sila pwedeng pagaluin. Tulad na lang ng oil at saka water. So, ang water and oil come together, they do not form a bond with one another. Kasi nga, polar si tubig, non-polar naman si oil. So, kahit na i-mix pa natin, i-mix yan. Because their polar molecule are attracted to one another and will form a hydrogen bond, which separate the water and non-polar oil molecules. Kaya nagkakaroon sila ng layer, eh, na?
In addition to the discussion that we have here, I would like you to perform some experiment as part of your performance tasks in this module. So dito, ang gagawin natin is to perform the viscosity. So in a later discussion natin mamaya, you will notice kung paano gagawin yung viscosity. But for here, I will be going to give you some instructions on how you can perform your performance tasks. Bago nyo panoorin yung video mamaya kung paano ginagawa yan. So ang gagawin nyo lang is to choose a different types of liquid, no? Whether to use vinegar, honey, syrup, o kaya water. Bahala na kayo kung ano gusto yung substance, and then experiment kung paano nyo gagawin yung inyong performance task. Make sure you have to take note kung gaano kadami or kung gaano katagal siya bumabagsak sa bottom, no? Panoorin niyo yung video na gagawin ko mamaya, and then ganun yung gagawin ninyo. And you can use paper plastic. Kung wala kayong mga basong glass, you can use the paper plastic. Transparent dapat siya para pag hinulog nyo yung bato o kaya marble, no? Kitang-kita ninyo kung paano siya babagsak at ma-measure nyo kung gaano siya katagal or kabilis bumagsak, no? Take note of the time. So gagamit kayo dito ng oras. As part of the proof natin, lagi ko sinasabi na you have to take a video and then upload that to your Google Drive para masigurado natin na you perform your performance task, and make sure nakitang-kita yung face ninyo doon, no? Kung halimbawa na magkapatid kayo or pinsan and you are enrolled to my subject, physical science, you can do your performance na iisa na lang para hindi na magpagod, no? Isa na lang at sabay kayong gagawa ng experiment, then upload the same video sa inyong Google Drive. Okay?
Dipole are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule.
What is dipole? Well, a polarized molecule having partially positive and negative poles is called dipole. For example, consider a single molecule of hydrogen fluoride, and we know hydrogen atom and fluorine atom usually share one pair of electrons and from a covalent bond. And this molecule, fluorine, is more electronegative than hydrogen. It pulls the shared paired electrons more towards itself than hydrogen, due to which electronic clouds. As a result of this, partially negative charge appears on fluorine and partially positive charge appear on hydrogen. But listen carefully, this is a single molecule. It has two poles, partially positive poles and partially negative poles, due to electronegativity difference. Instead of these two, we write di because di also means two. So we say dipoles. Therefore, the single molecule hydrogen fluoride is dipole because it has two poles, positive and negative poles. What about a single molecule chlorine gas? Is it a dipole? The answer is absolute no, because the chlorine atoms on each either side pull the shared electron equally. Electronic clouds remains in between. As a result of this, no partial negative and no partial positive side appears on either side. Hence, it is not a dipole. Therefore, you have to note it down that a polarized molecule is a dipole because of having positive and negative poles, like hydrogen fluoride. While a non-polarized molecule is not a dipole because no having positive pole, positive and negative pole. But what is dipole-dipole force? And what is dipole-dipole interaction? Well, consider a single molecule of hydrogen fluoride. And we have learned in the previous slide that it is a dipole because it has positive and negative pole. Consider another molecule of hydrogen fluoride. It is also dipole because it has positive and negative pole. Now we have two dipoles. This is one dipole and this is one another dipole. Here, listen carefully. The negative pole of this molecule attracts the positive pole of this molecule. Let me repeat it. The negative pole of this molecule attracts the positive pole of this molecule. Due to this, attractive forces generate between these two dipoles, which we call dipole-dipole force. It is because the negative pole of this molecule interact with the positive pole of this molecule, and dipole-dipole force produces between them. Remember that we usually represent the dipole-dipole force with dotted lines. Let me also give you another example. Consider another molecule of sulfur dioxide. And this molecule, oxygen is more electronegativity than sulfur. So partially negative charges appears on oxygen atoms, and partially positive charge appears on sulfur. The sulfur dioxide is a dipole due to having opposite pole. Now this type of sulfur dioxide interact with another sulfur dioxide. In such a way, the negative side of this dipole will attract the positive side of the sulfur. As a result, dipole-dipole force produces between them. Remember that due to dipole-dipole force, millions of molecule dioxide are joined together. Thus, the dipole-dipole force joined together polar molecules. Finally, noted down this bonus stage. Dipole-dipole force is not a chemical bond. It is intermolecular forces between
high melting point, high surface tension, low vapor pressure, low volatility, soluble in water, and we have low boiling point, low melting point. Halos kabaliktaran siya ng non-polar doon sa polar naman. Ganun lang yan. Kapag low vapor pressure ang polar, of course, an unpolar high vapor pressure. Alright?
Properties of a substance. Boiling point. Temperature at which the vapor pressure and atmospheric pressure of a liquid substance are equal. And water vapor pressure exerted by a substance in its gaseous state. So let's have an animation.
As we add heat to water, water molecules becomes faster and some of them spread out and form a gas. Ang tawag natin doon ay water vapor. And that's with inside the bubbles. Kapag nag-rise ang bubbles on the surface, ito ang tinatawag nating boiling. So, start tayo sa water molecule. And we have oxygen and hydrogen. So, dalawang hydrogen and we have oxygen. Ang tawag natin dyan ay H2O. Ang water molecules natin are always moving. Kapag may heat, moves faster. Kapag naglalagay pa tayo ng maraming heat, talagang kumakalat sila at nag-spread yung gas at nagiging water vapor. Kung titingnan mo, halos magkakahiwalay na sila. Merong mga empty space. To understand why bubbles forms while boiling, imagine natin lahat dito sa mga atoms natin. Some of them spread gas and form a water vapor. Kapag nag-ihiwa-hiwalay sila, ito yung tinatawag nating bubbles natin, bubbles at saka nag-rise. So, remember natin, bubbles only contain water molecules in the form of gas. So, pag kumukulo siya, no, aakyat siya at tawag natin dyan ay water vapor.
Melting point. Temperature at which solid becomes liquid. At this point, the solid and liquid phases exist in equilibrium.
Melting point of ice. So sa ating experiment, mangailangan tayo ng ice cube, beakers, thermometer, stirrer, stand with a clamp, wire gauze, tripod stand, and Bunsen burner. So kukuha tayo ng ice cube, ilalagay natin siya sa beaker natin. So ito yung proseso natin para makita natin kung paano siya matunaw, yung ice. Ito yung tinatawag nating melting point. So, ilalagay natin si beaker sa wire gauze. Doon sa taas ng tripod stand, lagyan natin ng stirrer. And then, lagyan din natin ng thermometer. Lagyan natin siya sa stand with clamp. At ilalagay natin sa baba. Ito yung use para makita natin kung talaga nagme-melt na yung ice at makita yung temperature. Lagyan natin ng apoy, yung Bunsen burner. And then, once na nakita natin na natutunaw na siya, pwede naman natin siya i-take note kung anong time. No, lagyan natin T1. Kapag natunaw na uli, i-measure na uli natin yung time 2. So makikita natin na yung ice, pag na-melt na siya makikita naman natin na pataas ang pataas yung tubig kapag nagme-melt na siya. Alright? Another one is the surface tension. Surface tension is energy needed to increase the surface area by a unit amount. And the other one is viscosity, what we call the resistance of the liquid to flow. Itong topic natin, pag-uusapan natin ay surface tension and that ties to water to surface tension to this property of a liquid. So like water that resists to an external force. Kasi yung water molecules, they are sticky and these can stick together due to hydrogen bonding and form the surface tension. Ito yung example natin na insect, itong water strider na to. It's pushing down, gravity is pulling it down. But the water is resisting that push because of the surface tension. So it can be on top of the water. Kahit yung mga nasa space station, sa outer space, surface tension that making waters stick together and form this ball. So looks this diagram. Assume natin ang black ball, black dots, they are the water molecules. Water molecule in the center of the liquid, like at the center of that sphere we saw on the space station. Those water molecules in the center have more opportunity to bond, form weak hydrogen bonds with other water molecules. Pero yung water molecules doon sa surface, nakikipag-bond lang sila sa molecules sa ibaba nila, one next to them because there are fewer of these bonds are stronger and that create a surface tension. Tingnan natin yung simulation ng water molecule para mas maintindihan natin. So may mga group of water molecules dito. 3-dimension ang animation na to. If you have to look them closely, yung red, lagi naka-point lagi doon sa white. Because of the water molecules, the oxygen and the red's little more electronegative. So this kind of a little more negative and the hydrogen's more positive. So nag-line up siya sa positive at saka negative and attract each other. And you will see that all these molecules. So lagyan pa natin ng mga hydrogen bonds. So nagkakaroon siya ng green kung ano yung attraction nila. Alright? So, they are not strong enough to influence the properties of water. In real life, these molecules will be moving. Let's do that. Okay, tingnan natin lahat. So, ayan, gumagalaw lahat yung molecules. Nag-move around siya and makita natin na breaking and reforming and they loosely forming in the sphere. Just like we saw on the sphere. Lagyan natin pa ng maraming molecules. Ayan. So we have a bunch of water molecules, and you can see them on a pointed and white side pointed at the rods, the reds, and the hydrogen bonds at the them in roughly against take the shape of a sphere. So ang nanonotice natin dito, yung atoms on the outside of the surface of the sphere, they can form as many hydrogen bonds as the atoms on the center. That's the surface tension. Because they can form as many bonds, these bonds are going to be stronger and they create a surface tension. And will actually force the water to take the shape of a sphere. So let's continue discussing viscosity. No? How to measure the viscosity of a certain fluid. So sa experiment natin, we need marbles, graduated cylinder, we have vegetable oil, engine oil or motor oil, dishwashing liquid, dish soap, syrup, and we have honey. So engineers often work with different types of fluids, therefore they need to be familiar with the properties of fluid as one of this viscosity. So the ability of the fluid to resist force is what we call viscosity. So how long will the marble to get to the bottom of the vegetable oil? So let's see. So parang 0.24 seconds siya. So yung engine oil naman, tingnan natin kung more or less viscous than vegetable oil. So it takes like 1.21 seconds. So let's test the other fluids, compare their viscosities. So tingnan natin yung dishwashing liquid. So it takes like 4 seconds to get to the bottom of the liquid. Ito naman syrup. So ang syrup ay 8 seconds. And we have honey. Honey, umabot siya ng 17 seconds.